Okay, so we're starting to transition now into more sophisticated methods of comparison. So whether we're comparing different projects competing for the same resources and priorities, or whether we're considering multiple paths to achieve a particular outcome, the cost-benefit analysis, the multi-criteria decision analysis, great little tool to, in a very modest investment of effort, do a comparative analysis between different options. So the multi-criteria decision analysis, so, some of the advantages of it can use both numerical inputs, so typically for us be monetary, or qualitative factors can also be factored in. And we'll see some of that as we look at some of the examples. And normally in doing this, we're going to use some kind of a weighted factor scoring model. And all that says is that not all of the factors have the same impact on the benefits. So we want to be able to make those that are most important more important, and those that are least less important in the scoring model. And so we're going to use weighted factors. So if we look at our weighted factor scoring model, this type of model allows us to establish a set of criteria on which we're going to evaluate each alternative. Now, each alternative will be evaluated against the same set of criteria so that we have a cross comparison between projects or methods or whatever it is that we're comparing. So we're going to estimate a weight for each of the criteria within the set, which will represent the relative importance of that criteria. Now, normally we're going to use percent, so all of it will add up to 1 or 100% for all of the criteria together. And again, that's probably a hint on best practice, easy to understand, easy to perceive. Certainly you can do it to the same effect using other values. It doesn't have to be a percent. It could go up to 100, it could go up to 10, it could go up to 1, it could go up to 5. But we work well when we're dealing with percent. So we're going to establish a scale using either graphs or word pictures with which we're going to use to evaluate the performance or contribution of each criterion. And it's really important that this scale be established before you do any of the analysis and set up so that we can eliminate as much bias out of the process as possible. And weights should sum to 1. We talked about that a little bit. Certainly using higher values indicate a greater importance or impact. The nice thing about using 1 or 100% is that it's very easy to see the relative weight. So we all intuitively understand that 30% or 0.3 is, about a third of the value if it adds up to 1. If you're using some arbitrary number, then it's a little less obvious to us when we're trying to figure it out. So the suggestion is that you limit your set of criteria to about 8. It's probably not a bad idea, because beyond that, the relative importance, the amount of importance is going to be very small. And so some of those criterion are going to have very small impact. And one of the things you're going to see is we actually, the absolute number differences aren't that important when they're small, right? Because it's not that finely tuned. So having a whole bunch of criterion adding in here is probably just going to confuse things and not benefit us to a great degree. So, as we said, small differences in totals are not meaningful. Large differences in totals are meaningful. And so we're going to get a rank order. But if something is different, by 0.1 say 0.1 out of 10, that's not going to necessarily indicate that the other one is better or worse than it. There is within an error bar, they are functionally the same. Now, the other thing to keep in mind is that you may have established some criteria as go-no-go gates. So if you pass the gate, then you're going to consider the project or the alternative. If you don't pass the gate, you're not going to consider it. And so that may also play into the weighted factor scoring model, but it may be superimposed ahead of it or during it and needs to be dealt with separately. Now, one of the values of the weighted factor scoring model is it does set you up nicely to consider a sensitivity analysis. Now, we haven't talked about sensitivity analysis. We're going to talk about that in the next video. Sensitivity analysis, because of the uncertainty in all of this, yet to be represented in any way whatsoever, will allow us to adjust for potential errors in our assumptions and or forecasts. And so the nice thing is that the weighted factor scoring model actually accommodate that really nicely once you set it up. So let's talk a little bit about the evaluation criteria itself and trying to establish the values. Now there's no set way to do this, but there are ways to think about it. So the first one is numeric. So the example that I'm showing on the screen is for the return on investment. And so I'm showing an IRR, an internal rate of return, and a number of different values for it. And so in this case, I also have a word picture associated with it where it's, you've satisfied or not satisfied or, greatly satisfied your IRR. Now, establishing how the scoring goes with that, this is an example of one that might be both a go-no-go gate assessment. If it doesn't hit a minimum IRR, you may discount that option completely and not pursue it. Whereas if it hits that IRR, you may consider it at an increasing relative score for values beyond it. So there's a whole bunch of different ways you can do that, but you have to set it up in your word pictures so that it scores the way that your company policy and opportunities desire. We can also do qualitative satisfaction values. So for example, you're looking at a market survey and what your expected impact is going to be. And so it's more of a qualitative assessment as to what you're going to get. So again, a series of word pictures and values that you're going to associate with something that achieves those word pictures allows you to set up a comparative criteria that you can apply to multiple alternatives. Now, we should look and see how you can set up that scoring, because quite often, I guess the unsophisticated default is everybody just comes up with a linear scoring. And what I'm trying to imply to you, both with the go-no-go phase gates, or not phase gates, the go-no-go gates, as well as that a linear scoring may or may not be appropriate to you, depending on what the criterion is that you're trying to score. So a couple things to consider. So let's look at the first one, return on investment. We may decide, it's probably reasonable, that more is better. And, this could stay linear going up. It could be exponential. There's a whole bunch of ways to do it. Or you could decide that, once we hit 12, doesn't really matter. We're not going to give it a higher score of going beyond 12. 12 is good enough, and we'll let the other criteria decide. It could have a score below which it's getting 0 points for that. Or, again, as we implied when we set up the table, it might be that you're going to say, below 4%, 6%, 8%, whatever that value is, we're just going to take this alternative away and not consider it anymore. So it may also be that gate. Now, it's equally possible that you actually don't want more is better. What you want to do is to focus in on a specific target. In the example that I've chosen, let's say you're looking to hit a particular target audience. Maybe it's a hole in the demographics that you're not servicing particularly well. And so you're focused very much on that target audience. You don't care if you broadly spill outside of it. Matter of fact, maybe you don't want to broadly spill outside of it because now you're just competing with yourself. Maybe you already have the market share outside of that target audience. And so you want to stay fairly constrained to that. And so you set up your assessment criteria to give you a very strong value if you're tightly hitting that target audience, but you're going to drop off on either side of it if you're missing it. And in other criteria, it may also be that less is better. So time to completion. Obviously, if it's going to take us a long time, we don't, we're going to score less. If it takes us too long, maybe that's one of those gates where we're just not going to consider it because it's not worth the investment. It's going to go too long. So coming up with these kind of criteria and how we're going to scale it shouldn't be a simple process. This is the time when, if you invest now into each of the criteria in your set, as well as the set itself, you're going to establish whether your model is going to reflect good decision making or not. And it certainly doesn't have to be absent of sophistication, nor does it have to be hugely sophisticated to be effective. But you do have to try to give it get it working. So let's look at a quick example. So an evaluation criteria, setting values. So consider your evaluation criteria for the pro's new camera development. And so we're going to make a new camera. That's the business we're in. And we're considering resolution. And so in contemplating what we want to value, how we want to score this, this is the picture that is posed to us, is that we know that higher resolution is better. Okay, that kind of goes without saying. But we also know that we need a minimum of 8 megapixels for it to be acceptable in the current market. Below that, we're going to miss the audience. They're not going to be interested in our product. And so we know we need to hit a minimum of 8 megapixels. We also know it is better to get more. But the audience only values enhanced resolution as a hedge against obsolescence, right? Once they get to a certain degree, they don't care anymore. They know they're going to get bigger and bigger and bigger in the future. And so you don't want it to become obsolete too quickly, but it's a falling off scale as far as how it will be valued by the people that you're trying to sell this new camera to. So you know that greater than 12 megapixels then, in this circumstance, would be wasted given its intended use. And so if we were to look at that, we may set up a criteria evaluation, which would go linearly from 8 megapixels as a minimum up to 12 megapixels as a full score. We're not going to cut it off. If we get higher than 12 megapixels, we're happy with that, but we don't want to invest in getting higher than 12 megapixels. So we've got our score at 10, maxed out at 12, and we're not going to give any more score for higher resolution beyond that. So now, alternatively, if we looked at cost, and so I'll read the narrative. So market survey indicates that a price point between $150 and $250 should succeed depending on the options and how they compare to the competition. So, we've got our range, but we also know we have to pack it with the right features. And it's really the features that are going to compete with our competitors as compared to the cost. Now, while cost is important, it is dependent on what options are provided relative to those alternatives, as we were just saying. So for argument's sake, let's assume a price below $150 is not desirable. It's not going to be perceived as a competitor in the market niche that we're trying to penetrate. So perhaps we would set this up to score this criteria, and it would we don't want it to go above $250, and so it's going to get a 0 score above $250. At $150, it's going to get the best score. So if the most features we can get at $150, that's great. We're going to give it its maximum score. But then we're going to drop it off quickly below $150 because now it's not actually going to be focused on the target audience that we're looking at. So weightings are just as important and perhaps even more difficult to be objective. Weights are necessarily relative. So basically what that's saying is which is more important, resolution or cost? And so we're going to have to, now that we have a score, an evaluation for each of the criteria, now we have to figure out which one is more important than the other. And so we're going to have to consider weights. So let's look at our decision matrix. So, this is just a table that is going to do our multi-criteria decision analysis for us. So in this matrix, we're showing rows representing the various criteria within our set, and the columns are the various alternatives. So we have 3 alternatives shown in this table: alternative 1, alternative 2, and alternative 3. So a separate column is used to show our criteria weights, and we see that each of our 6 criteria have a percentage weight, and they all add up to 1 or 100%. So then within the cells of the matrix under each of the alternatives, we need to arrive at a score. And this is where we're going to use those criteria scores that we talked about a couple slides ago, and we have to figure out what they are. So we're going to use a scale of 0 is the worst and 10 is the best. 0 to 10 is a very common and easy to comprehend, easy to understand assessment. We work really nicely in the decimal world. We can choose anything else you want. It's just not going to necessarily be as intuitive to understand its relative balance. So we'll use 0 to 10, and the evaluation criteria can be a mix of numeric, i.e. our profitability discussion that we have, or qualitative, maybe a values alignment or some other qualitative criteria that needs to go into your assessment. For each alternative, we multiply each rating by the corresponding weight and sum to get an overall score from 1 to 10. And as we said before, we know that small differences in score are more or less meaningless and aren't going to really reflect a difference in the value proposition from one alternative to another. So setting up weights and evaluations is complex. Certainly I've used these for project assessments. I've used them for contract assessments, for acquisitions and whatnot. And I will say that you probably need to tune them blind of what your true alternatives are. So before you sit down to actually score against your alternatives, it may be necessary for you to tune them using simulation on fictitious projects, so that you can make sure that they are getting the relative weights in accordance with the real weighting that you need to reflect the impact that it's going to have in the long term. So some degree of tuning, it's a complicated beast, but it is certainly worth running through some fictitious projects to make sure that you're getting back numbers that make sense to you before you start looking at the actual projects themselves. The problem with trying to tune it with the actual projects, of course, is that now you're introducing bias, because really all you're doing is you're fudging the numbers until you get the project that you think is most appropriate. And that's not really what we're trying to do here. Seen it often enough. So decision matrices, the decision matrix summarizes information about the multiple objectives, which is a really great opportunity. It's an additive utility model, and it permits us to calculate an overall score for each alternative. It's a relative score, and a comparison of those scores will indicate, hopefully, which is the best alternative for us to pursue. So the advantages of this scoring model then allow multiple criteria. We're not locked into just one criteria, like net present value. Net present value could be a single criteria within the set of criteria that we're looking at. Structurally simple to set up. It's not complicated. Mathematics is not difficult. The logic is fairly obvious. It's intuitive and reflects our actual thinking processes. Direct reflection of managerial policy. So, we talked about values alignment was one of the criteria criteria that we used in the last example, if there are policies or overarching value propositions, they can be easily incorporated into the decision analysis. They're easily altered. We can change out the criteria set. We can change the weightings. We can change the how we evaluate each criteria to make it function appropriately. And it allows for more important factors. So not all factors are the same. So that's the real benefit of weighting them. And it also allows for fairly easy sensitivity analysis. I know we haven't demonstrated that here, but it does incorporate really nicely into a sensitivity analysis. So some of the disadvantages, it's a relative measure, which is to say it's not an absolute measure. It doesn't have any intrinsic meaning other than how it scores relative to the other alternatives. It's usually linear in form, so I think it's a limitation of how most people think. It doesn't have to be linear. It certainly could be exponential. It could be uniform. But I would say most people doing this approach it from a fairly unsophisticated manner, in which case their scores are quite often linear. But it doesn't have to be that way. There is much more flexibility in the system than is represented by that. And you can have a large number of criteria. Again, at what point in time does your assessment become insensitive to some of the more minor criteria, and then you may as well just drop them all off. Unweighted models assume equal importance. That's a disadvantage. Obviously, the advantage to weighting them then is to, if your criteria are not equally weighted, then you should be using a weighted model. So that's really just a quick blast through of how to do a multi-criteria decision analysis using a decision matrix for assessing different alternatives. I'd be surprised if most of you haven't seen it at some point in time. They're used for anything from tactical decision making to business alternative assessment, and it is one of those tools that, quite frankly, you should have a mastery of moving forward and use it when it's appropriate to you.